Hi, welcome to Source ZeroCon 2022. My name is Angelo Castigliola, and today I'll be presenting on advanced database security testing. So real quickly, I'll go over the agenda here. We're starting off with an introduction, who I am in my role for Optiv. I'll be going over sort of what this talks about and sort of how it came together. I didn't want this presentation to be just about database vulnerabilities and database testing just from a manual penetration application testing perspective. I really wanted it to be the comprehensive look at, when we're doing database security reviews, where we're looking at the type of controls that we're looking at, and what we're thinking about, data that's being stored on the databases and encrypted, looking at the users on the database, the permissions, their passwords, the policies around that, just really just that bigger picture of than just that the most common avenue of sending data, to the application, to the API, down to the database, has it being processed, and looking for a vulnerability from there. Just look at the other layers of attacks that can happen with a database, those other vulnerabilities that kind of should be considered. We'll start with a real basic textbook, since we're talking about SQL injection so much during this talk and injection vulnerabilities. We'll just make sure the audience is really level set on just a really basic SQL injection. And then we'll talk about NoSQL and ORM and how SQL injection and injection vulnerabilities play a part with those databases. And then we'll get more into the advanced topic of advanced database security testing. I'll be reviewing database timing attack, and looking at the different scenarios that I've seen when working with those types of vulnerabilities and doing that type of advanced testing. And then again, we'll look at the database security as a whole, the whole, look at the different controls. One of the things you have to remember, when we're talking about databases, it's just not that database component itself. We're talking about the database server, the host operating system, the database server running on that host operating system, the database that's there, and then you think of that as your database, but there's other databases that's running on that database server with their own users and own permissions and own security policies. And so really kind of looking at it from sort of really comprehensive view. And then I'll take a look at some, from doing these types of assessment, the common findings that I see out in the field, and then we'll just sort of wrap it up with the conclusion. So who am I? I am Angelo Castigliola. I'm a technical manager with Optiv and application security. I've been with Optiv for 10 years. I have over 15 years experience in enterprise security. I specialize in application security, mobile security testing, API security testing, code reviews, database security reviews, secure SDLC, certified in mobile application security testing. In 2010, I was presented a cybersecurity award from the Department of Homeland Security for contributions to the White House cyberspace policy review, the comprehensive national cybersecurity initiative. These days, I'm really excited about blockchain and Web3/5, and sort of with that, those technologies are offering content creators and sort of this content creator economy, and how that technology can help push that to new levels that we've never seen before. There's a lot of enthusiasm and excitement in this blockchain space, and sort of how it's going to revolutionize the internet. I'm a big believer in it, and very excited about it, and seeing that technology move forward and being a part of it. So getting back to my presentation on advanced database security testing, So again, I really wanted this to be like a very comprehensive talk on database security, not just manual penetration and looking for that SQL injection vulnerability. For a long time, um, there really wasn't a lot of documented research from security researchers on database security. And at the same time, there really wasn't a lot of published write-ups from database administrators on what they do, the controls that they look at, the controls that they're concerned about when it comes to the security of their database. There really just wasn't a lot of overlap from those two job roles producing that information. And so I with this talk really is just all that information I gathered over the years of doing database security and looking at these types of issues, and really putting this comprehensive talk. I really feel like what you'll find here is a lot more information than what you would find if you do a search for like database security on OWASP. There's a lot more information here. Um, we'll briefly talk about, once we identify these vulnerabilities, how to remediate them. We'll just kind of real briefly talk about the secure systems development lifecycle, the secure SDLC. Um, and then again, just review database assessment methodology, look at some common findings that we see when we're doing these assessments out in the field. So let's just get really level set here. This is a very textbook SQL injection vulnerability. In fact, it really doesn't get much more textbook here. We have a string, we're calling it a query. We have the string, we're calling it query. And it's doing a select account balance from user data. This is the table we're working with, right? Where username equals, and then we sort of stop here, and then we tack on whatever username that's being entered by the code. So whatever username that user types in, or wherever that data comes from, it's dynamically getting added to the SQL query that's being ran on the database server. And this, since we talk about SQL injection so much, this is what we're talking about. It doesn't matter what programming language, what database server. When we're talking about SQL injection, this is a dynamic statement that we're talking about. And so, obviously, you have select account all the way to username. This all is static. This last piece changes here. This is the dynamic query that gets ran. And so the obvious fix here is to parameterize your SQL statement so that when it gets to this query, if it's parameterized, the SQL server knows, hey, this information, this little bit of data right here is just a parameter for this query. It shouldn't be embedded into the query itself. This shouldn't be, telling me to join another table and looking at, and select star from, a sensitive data table. It's not a part of that query. So that's, really just getting to the real textbook of what we're talking about with SQL injection. So, when we're talking about SQL injection and sort of doing security awareness, where we might be talking about just OWASP top 10. A lot of times developers will bring up NoSQL, and there aren't any SQL injection vulnerabilities for NoSQL, or we're using the Hibernate ORM database. There's no SQL injection for those databases. And, there's some truth to that, and so I kind of just wanted to break that down a little bit. So for NoSQL, does NoSQL mean NoSQL injection attacks? It is true that classic SQL injection payload, the so the select star from select star from some sensitive table, those types of payloads aren't going to translate to NoSQL database platforms. You're not going to be able to run those types of queries. But NoSQL databases do have their own injection parameter, injection payloads. And so, one of the injection payloads that you can submit to a NoSQL database can actually change what the query, how the query flows. So, example of that is, you might say, give me all the data that belongs to this client, and that's how the NoSQL processes that database request. But it is possible to inject parameters or payloads into that query so that the NoSQL, it changes the logic of that NoSQL database statement. And what you might have is show me all the data that doesn't belong to this client because of that payload that you put in there. So there's other injection vulnerabilities, and once you run that payload, now you're looking at all the other clients, not the client that you were asking for that you might only have permission to. In some cases, you can execute JavaScript functions server side from a NoSQL injection. So that is a possibility. It sort of is unique code case in that perspective. One thing to consider about NoSQL databases is, they often come out of the box with security features disabled, and you really need to take a look at those security features. It could be logging, it could be administrative features, it could be any of that. A lot of that's just disabled right out of the box. And then, when it comes to object relational mapping databases such as Hibernate, again, the classic SQL injection vulnerabilities, they can exist, but for Hibernate, it has to be, very poor, non-standard code to have SQL injection in those types of databases. But as you're talking about databases and security and SQL injection, those two types of databases might come up, and that's sort of the information about secure, where SQL injection and security, how it kind of plays its role in those databases. So, I'd say the most efficient way to remediate SQL injection vulnerabilities from a code base is to do a static application security testing. This is code scanning. It's an application that, or software that scans the code base, looks for, and it's very, very good at identifying SQL injection vulnerabilities in the code base. If anything, there'll be false positives. There could be legitimate reasons that, if you have a sales forecast or a sales application or some sort of data, an application where you have to really build dynamic queries to pull data out of a system. There could be very legitimate use cases for dynamic statements where you wouldn't use parameterized queries. And for applications like that, there's different whitelisting techniques that you have to put in place to remediate those, but they do exist. But the main point here is static application tools. They really the best way for a developer to check their code for security vulnerabilities as their development, remediate the findings with the vulnerability management process, whatever that is, and then as you use like static application security testing is an industry standard as part of the secure software development lifecycle process, the secure SDLC. So it's industry standard now that as developers are writing code, they're checking their code with a code scanner that's looking for really basic vulnerabilities that can have severe ramifications if left in the code, such as SQL injection attacks. And this is the whole shift left um, goal, all right, of having, shifting security as far left, as close to the development process as possibly can. Um, you know, um, and it's definitely worth mentioning, that manual application security testing is still really important. Um, uh, and we'll sort of show that when we're looking at sort of more advanced um, SQL injection or more advanced database security testing techniques. Um, but you know, the other piece of having uh, static security testing, static analysis, um, in the code processes, as you're getting this information, this visibility, you're seeing the common types of findings that are in the different code bases for the application portfolio for your enterprise, and that allows you to make a standardized a standard that developers, a coding standard that developers can easily check their code with, to make sure that the code that they're writing is in compliance with the secure coding policies of the company, right? Everything's defined. Developer can check it real quick with this tool. My code either passes or fails. And it gives, it gives developers a really easy standard to follow, to make sure that they're meeting those policies and standards. And then you use that information to build on that policy, and then offer any kind of like really targeted security training. As you're finding these vulnerabilities in SaaS. That's why SaaS is just such a big part of the secure development lifecycle process, and just really an industry standard. I just kind of wanted to drive that home. So when we are talking about sort of advanced timing attacks, so when I'm doing a manual penetration test for either a web application or a mobile application, and I'm doing a timing attack, this is what I'm looking at. And so um, this is a burp repeater tool. And so I just have a simple request in here, and it's just doing a real quick login. And you can see I have non-existing user, and I just put test for password. And the important piece here is this 349 millisecond response. And that's the information that I'm looking at. And so, a really simple sort of, when we're doing manual application testing, we always look for user enumeration. We look at the forgot user password functionality, or we look at the change password functionality, or change username functionality, and we see if we can enumerate other users on the system, and those can be, those can be used for other attacks against the web application. And so, and we're always looking for user enumeration through those processes, and those are pretty easy to spot out if you get different responses for, a valid user or a non-valid user. But in this type of scenario, where we're looking at timing, if we have a non-existing user, since there's no data to sort of look at, there's nothing really happening there. We might get like a really, really quick 349 millisecond response. But if there is an existing user, and then we're sending a password, and that password we're sending needs to be hash, and that hash needs to be ran against the database table and compared. Does it match? Does it not? doesn't match, front to back. It takes more time to do that. And so I might be able to put a valid user in there, and then my request might every single time take at least 700 milliseconds to respond. It's still very fast, but slightly off enough that I can tell that that user exists or doesn't exist just by how quick of a response I'm getting from the database. So user enumeration might seem a little bit sort of benign, but when you're working with web applications that have sensitive information in it, might be sensitive names. It could be uh, uh, a HIPAA protected application where it's got very sensitive medical data, uh, where even things as like policy numbers, clean numbers, those are all considered very sensitive information, can't be disclosed. If I have a really simple function that when I put a policy number in, I get a response saying, that's, you don't have access, you don't have authority, you don't have permission to look at this policy. But the policy number, that doesn't exist, it might take, another 349 milliseconds to return. But a policy number that does exist, there's more data, there's more things happening, that might take like 600 milliseconds consistently, time and time again. And so you can start extracting, you can start thinking. And so whenever I'm doing uh, manual security assessment for an application or mobile security testing, I'm always looking for that type of sensitive information that I could sort of run in like a timing attack and just start seeing like, can I get the database to tell me if this exists or not with, just by the timing. Um, and, obviously that you can see that, um, you know, this type of vulnerability, a static application or a code scan is not going to pick up that type of vulnerability. It's very similar to when you're reviewing the business logic, right? There's a lot of business logic that happens that really needs to be manually tested, that no dynamic application security testing tool is going to pick up automatically. So we've talked about, again, look, we SQL injection and looking at some different attacks kind of coming through that main, entrance of data that you put in the application or the mobile application that gets eventually makes it back to the database and looking from there. But when we start kind of getting into the database security assessment process and really assessing the security posture of a database instance or a database server, um, you know, really what you have to remember is that there's the database server itself, there's the host operating system, there's a database server running on that host operating system. That database could be multiple databases there. And so we'll just kind of get into that aspect of looking at those types of um, breaking down the database, not just thinking about that database component, but breaking down all the different layers of and taking a look at that. So starting off with the host server, the host operating. So this could be Microsoft Server 2012. This could be Microsoft Server 2019. This could be Linux servers, could be a Unix server. This is the actual host operating system. So there's a lot of things that we look for when we're assessing the security of the host operating system. One of the things that we look at is it just a database server? You every once in a while you'll see a database server that's also running IIS for some reason. And a lot of times IIS is turned on by default through the server through the internal server deployment process. So typically Internet Information Server, IIS, the web server, or even on a Linux server, or a web server running on that Linux server. that might just be a standard part of that deployment. When that new server goes up, and then they just dedicate it to a database server, and it's not even being used. It's set up in the very default way. So we look at things like that. We make sure that this is a database server. It's just running database processes and not any other sort of platform services. It's not running email as well and things like that. We look at really very common things. Is the host server fully patched? I've definitely come across a database server that was missing, over 100 patches. It's just, and you talk about, a server just completely unpatched, and it just takes the right access to get there and just completely take away. The server is just a sitting duck when it's just in such bad shape, but that does happen. Sometimes servers are neglected. Um, not only is the server patch, but there's also various patches for the database server itself. So if it's running, MySQL or Oracle or Microsoft SQL Server, there's going to be service packs. There's going to be update packs that have to be applied to keep the security up to date for the database server itself. So that's a whole nother set of patches that usually the DBA is more aware of than sort of the server engineer. So those are always often overlooked as making sure it had the latest critical patch updates and things like that. Um, you know, Another really easy thing to overlook is there some sort of separation of access to the database server. Typically what you want to see is a firewall policy that only lets the application servers who are that need to access that database server to access the database, only let that traffic through, that a user can't just be on your network and just start running through and connected to all the database servers on your network. We like to see some sort of firewall policy that's sort of blocking those database servers off. And then one of the most important things that we start looking at is how is access provided and who has access to the database. When working with Microsoft SQL Server, it's very common to see that domain administrators and domain user groups have access to the database server simply just the way that just just the way that the server was configured, the security permissions on that server. It's very common to see that. So you have a lot more people with access to your database server than you intended or are aware of. It's very easy to overlook. We also make sure that access that is granted to users is done through groups. We make sure that there aren't just users that are being thrown willy-nilly into fixed server roles to access the database, just directly added sort of ad hoc. We would like to see some sort of structure and process around there. And another really big one when we're looking at the database host server, right? The Windows server, where are there file shares open on the database server? Every once in a while we'll pull up a database server and there'll be file shares all over the server, sharing like all different aspects of the server to everyone, or to authenticated users on a network. So there's a lot that can happen there. It's very, very easily overlooked. A lot of times when resources like that are being shared, nobody's going over and checking that those are being closed back up for whatever reason. So yeah, that happens a lot. Um, we also look at the file system. We look at the local policy. We look at the system event levels. We make sure that logging is happening for that. So if there's any type of incident response that needs to happen, the worst thing as an incident responder is to come in and you're trying to you're trying to piece the events that happen as part of an incident, and you look at the server and there's no logging. It just was never turned on. There's no auditing. So having that auditing turned on the file system when you're responding, it's the difference of knowing what happened and not knowing what happened. It makes a huge difference. And another common issue that we look at is a lot of times we'll see that the database server running on the host operating system, it's running under a high privileged account, either administrator or root. It doesn't need to. And obviously if somebody's able to execute commands through the database server, well, they're executing commands as an administrator and not as a non-privileged user. So that's why that's really important when looking at the host server. And this isn't by any means an exhaustive list of all the things that we look at on the host, but this is sort of to kind of give you an idea of these are a type of things that we really need to consider when we're looking at database security and the security posture of a whole database. Um, you know, so now that we looked at the host operating system and what's running the database server, now we open up the database server itself and look at that database and the data that's being stored in that database. So one of the first things that we do is we go through all a lot of these tables as much as we can, as we go through all the tables and we look for anything that's not encrypted for passwords. If there's any kind of payment card information, if there's just sensitive information, it should be encrypted and just not left there. Sort of just sensitive information should be protected when it's left at rest and just not sitting on a database server. Um, you know, Another big piece, and I think is a very big important step when doing a database security assessment is, if it's a Microsoft SQL Server or if it's Oracle, as a database administrator, you have access to those password hashes, and there are plenty of tools for running a basic wordless brute force, very standard out of the box, especially for Microsoft SQL Server and Oracle, where you can just run those common passwords. And so what I like to do as part of a database security assessment is grab those hashes, run just a really quick, very basic word list through there. And some common passwords that I found is things like passwords. I found accounts with like Web App One and Vendor Portal. If the you know if the the if the database administrator has the uh, users authenticating to the database itself. So they're not using like Microsoft authentication or some sort of network authentication to authenticate to the database server. If you're just doing like a SQL login, and you're just using a SQL password, you really find that those passwords that are being set are probably have no password policy that matches the complexities that you need when you're setting the password for your desktop or for your laptop, or for your email. Those password policies fly under the radar. And one thing to consider is, you have a database server. It's not just your database for your application. There's going to be multiple databases on that database server. Each one of those databases has their own users that could log into the database server, that have their own permissions. And the DBA is typically the person that are, identity and access management gives the DBA an account on these database servers, and the database administrator can create their own users on these servers. And there's not, most DBAs will definitely try to follow policy and match policy with identity and access management. They're not necessarily a part of identity and access management. And these the policies, the password policies or complexity is really easy to sort of fall under the radar um, from these the overall enterprise password policy complex. So what ends up happening is you can have just very random users being created by DBAs with very weak passwords. So that's why I like to run just really basic word lists and just make sure you'll find accounts that have no password set. It's just really, really common. And a really, really great find when you're turning in a report, when you're getting a lot of really bad accounts off, or changed or fixed. Um, Another big thing that we find is, by default, especially for Microsoft SQL Server, there's a lot of modules that are enabled by default that allow you to do things like read the registry from the database or execute commands from the database. If you're not using that functionality, it's best to just disable, right? I mean, if your applications aren't using it, the only people who are going to use it are the people to abuse it. And so removing that, is just an easy fix. And again, it's one of those things that's enabled by default. And a lot of people just leave it on. And a lot of, when attackers get to the database and start pivoting and try to get into the network, that's the route that they're taking. They're using these registry commands, these extended modules, these extended procedures to elevate their access to the other point of attacks in the enterprise. And when I'm doing database security assessments, the most common finding that I see just about every time is around auditing, logging. A lot of logging is disabled by default for most database servers. And so that's always one thing we always call out. And again, we just want to make sure that things like, user when they log in, when they log off, when they do permission changes, those types of events are being captured, logged, and if there's an incident response that needs to happen, making sure that the incident responder has enough information to piece together what happened, and kind of can understand how much of a breach or how little of a breach happened. It's very important, and as a responder, there's nothing worse than not having that information. It's like having the lights on or off. Um, so I kind of wanted to cover some of the nitpicky uh, uh, you know sort of like, when I'm doing these database security assessments, these are just a little bit more, sometimes I feel like I'm just nitpicking here, but and I'll just kind of go over it. Like, so fixed rules, so one of the things I look for is if a user, it was just assigned like DB data reader, and so that role might give them access to all the databases on the server and not just the database that they need access to. So we look at things like that. Uh, you know, Disabling access for remote stored procedures and remote replications. Again, if you're not using remote stored procedures in your application, just turning that off just enhances the security layer. Ensure that logs can't be overwritten. If I'm an attacker and I am able to take advantage of a database, you know, if I can if I could tell that, if I can generate, a couple, maybe a gig, and a lot of times, log files might be set to like 100 megabytes or 500 megabytes. If I can generate that much data real quick with a script, those all that log data of what I did will be overwritten. And so making sure that, the logs aren't overwritten, or there's some sort of log preservation or log monitoring or log correlation system in place. That's one thing that we look for. It's a little nitpicky, but I mean, it's very important. Again, kind of getting into nitpicky is like Microsoft SQL servers. have a browser service. So they sort of announce, if you think like a Wi-Fi network, and you look for like the Wi-Fi networks in your, in your vicinity, there's a lot of, unless it's a hidden Wi-Fi network, you'll just see it pop up. Microsoft SQL databases also work like that. So if you're in a Microsoft Windows network and you open up Microsoft SQL Server Studio and you say, let me browse all the different databases that are a part of this network, and, your database will happily announce, here, this is my instance and this is how you connect to me. So disabling that just, sort of makes it, it just kind of gets the database off the radar. And then, getting more nitpicky is, one of the things I look for is making sure the SQL Server is installed on a different partition than a hard drive and operating system. Just make sure that the information is on a different partition, lock down that partition as much as I can, and in this sort of just like an old way of administrating SQL Server. So kind of getting to the conclusion. So um, there's a lot to think about when it comes to database security. There's a lot of different controls that can check. The database is more than just a server running on a host operating. It's more than just a database. It's a database that's running on a database server. It's running on a host operating system that has multiple databases, multiple users. So there's just a whole lot to it. There's a lot of things to check, and one of the things I want to say about the being nitpicky is, when I've done a security assessment and wrote up a lot of the nitpicky stuff, and then revisited that, you know, you know, same deployment, but after all those issues have been remediated, you really look at how much the security posture has improved on a database. It's a night and day. You're like, wow, this is really a lockdown database server. Like, this is really going to be hard for anybody to get through all these layers. And it's very impressive, and it's really good to see. And again, just like business logic, some of the advanced database testing techniques, the timing techniques, you're not going to find that with standard tools. And the same with like easy database security findings, like having sensitive data that's just sitting on a database at rest. A stack analysis tool is not going to easily pick that up. So thank you for viewing my source code, my source zero con talk about database security. If you have any questions, or if you'd like to learn more about database security, reach out to your Operative representative, and they'll definitely get in contact, and we'll get to the resources that you need. Thank you.